Hello everyone, this is Patrick, and today I'll be demonstrating how to train the SO101 robot with 100 faces in one robot. So what you want to do first is you want to create an environment using conda. Here we do conda create -y-n robot. Python equals 3.10. Now I'm not going to create that because I already have a copy of Lerobot here. So I have the Lerobot here, Lerobot environment here, and you run conda activate Lerobot to activate it. If you're using mini conda, you will want to run conda install ffmpeg-3conda-forward to install ffmpeg 7.x for the platform with the libs btag1 encoder. If your platform does not support it, you can just install ffmpeg 7.x. Using conda forward, as you can see on the screen here. But now the next thing you want to do is install the robot. So first you want to clone the repository, git clone https://github.com/huggingface/lerobot.git. And I typo here, but since I have already cloned this, I'm just going to go directly to the robot. And then you will just install, install -e every single, you'll install the library here. Once you have done this, you will have finished installing the robot itself. But since I've already installed it, I'll just cancel it here so it doesn't waste time. Additionally, you'll want to run, for the SO101 robot, you'll want to run this install -e.speedtech, which will install the speedtech SDK. After you finish installing it, you'll want to 3D print the SO101 robot. You'll need a number of motors as well. So starting from the bottom and starting from the base where the shoulder is, moving to the gripper, you'll want motor 1 with a 1:191 ratio, with 191 gear ratio. At the shoulder lift, you'll want a 1:3.5 ratio. At the elbow, number 3, you'll want 1:191 again. At number 4, 5, and 6 for the wrist flex, wrist roll, and gripper, you'll want 1:147 gear ratio motors. Once you finish assembling the arm itself, as you can find on robot's documentation on Hugging Face, you can now run Lerobot -find-port. Okay. You should be able to run it. Yeah, so once you find all the ports available for the motor bus here, you can disconnect when you find the ports, you disconnect the USB cable from your motor bus. In this case, I've already disconnected it, and now they know that number two is the arm that I've disconnected, and so on. Next step is to set up the motors. Here I run Python setup motors.py. It doesn't work because I forgot to specify. But as you can prove here, you can find okay. There. Once you run this setup code, you first specify your robot type and then the robot port. Here I will cancel it so I can show the code for the leader. As you can hit the command here for setting up motors, the robot type is equal to leader and the robot port is equal to what you got from the find port script. After you do this, you will need to connect your motor bus controller when you are assembling the robot to only the gripper motor and then press enter. Then connect it to only the wrist motor, press enter, and so on until you have connected every single motor to each other. And then they will be ready to go. Then you will connect the gripper motor to the wrist roll motor and daisy chain them together before finally connecting the shoulder-based motor to the arm itself. Now the next thing you want to do is calibrate the robot. You do this by running calibrate with the robot.type equals SO101 equals underscore follower. Robot.port equals /dev/qi ACM. Now I believe I had ACM2 as the follower here. And robot.type equals follower arm. I've already calibrated my robot, so I will not be running this. However, once you run this, you should first move the robot to the point where all these joints are in the middle of the ranges before you wiggle them around so that you move it to its full range of movement and your robot knows how far to go. Then you do the same thing again for the leader arm. The one with what you use to control the follower. And then you'll be ready to move on to the next step, which is controlling the robot in the real world. Here first thing you want to learn is how to teleoperate the robot. Here we're using the Python-m, the robot to teleoperate. We have our robot type here, our robot port, a robot ID for the follower arm. Next we specify the camera, where for the front camera we're using OpenCV. Index of path is 0 because it's def-y. ACM this you can find it using its own port system. You can then find the width and height of the camera and the FPS. Then we also have the top camera, which we specified here. And finally, you take your teleop arm type, your teleop port, your teleop ID, and display data equals true, so that you can run this with your camera on. Now I am running with my camera. This might take a little time to load. So here we have a little bit of troubleshooting, but so we have the robot port or Y15, and then we have the tele-op R. It's a little troublesome, but okay. I think I found the problem here. Here on Ubuntu, you sometimes have a problem where you can't access these ports. So you will need to change the permission. Now I am connecting to everything here. My side camera is off pointing in the wrong direction, but from the top camera you can see that the leader arm, the black arm, is controlling the movements of the follower arm, the white arm. You will note that it's also logging all these conditions as well. I will now go ahead and shut this down, because once we know how to teleoperate, we can now record the dataset. We will first do how to use based CLI login token. You put your token here and add to git credential. If you want to run everything locally instead, you can of course choose to record locally here, where, yeah, over here, you can see that we have a code to record the dataset. We record our follower's port, our follower's ID, the cameras, the leader's port and ID. We choose not to display data so that this screen doesn't get brought up and get in our way. We set a local repo ID to demo1 slash SA101 test1, which you see in Lerobot. We will have we should have this will take some time to find, but yeah, in the cache hugging face Lerobot, you will find the demo1 in the SA101 test1, which is where this gets saved. You specify the number of episodes, a description of the task. Here we say push to hub false because we are not logged in hugging face. We set the episode time of 25 seconds and a data set reset time of 10 seconds, which gives us 10 seconds to reset the task. Ideally, you want at least 50 episodes to get a viable data set for training. Once you're done recording, which will not be here to save time, if you want to upload your data set to Hugging Face, you can run echo https huggingface.co/data.set/username field. For example, here we have dcans/s1 test. This will upload it to dcans page for Hugging Face. But since I'm not logged in, I will not be doing that. Our data is stored in the Lerobot dataset format, and it is by default pushed to Hugging Face after recording. You can choose not to do that by doing dataset push to hub equals false, which is useful if you're not logged in or you just want to do everything manually. Checkpoints are automatically created during recording, and if you have an issue, you can manually resume by running this with control.resume equals true. If you want to record from scratch, you just have to go to this folder, cache Hugging Face Lerobot1, and delete this dataset directory. You already know what the parameters here do with the episode number, episode time, and reset time. And while recording, you can press the right arrow to end the current episode early, the left arrow to cancel the current episode and re-record it, and escape, ESC, to stop the session, encode your videos, and upload the dataset. You can also visualize dataset online by copy-pasting your repo ID, which is given by echo, let me click this line here, echo username /so1 test, where username is your username. For example, for here it could be Ken, or it could be Bob, or it could be Patrick, which would be, except my Hugging Face username is not actually Patrick. Now, if you want to replay an episode, you can of course run python -m lerobot.replay, robot type equals SA101 follower. You give your port ID, your repo ID here. Here I'm using the local ID here, so it's demo1 SA101 test. This works even if you're not logged into Hugging Face as is, and finally you can play the episode you want. As you may have noticed in my teleoperation clip, my follower arm is currently a little too close to my computer, so I will not be demonstrating this. But if you want to see which episodes look like what, you can run this command. Next, you can train a policy with Python M. Here, this uses a different format, but basically you run the Lerobot. You run the robot. Scripts train.py file, you get your dataset REPL ID, which is the dataset you just recorded. You secure a policy type to act, because the robot's acting. Your output directory to output tray, and then you choose a name here. You choose a job name. You set the device to CUDA to enable the GPU. And here you can select 1 dB to visualize the training plot. This is optional, but if you do use it, make sure you're logged into 1 dB. 1 dB. And then to resume training from the checkpoint, you just also you can choose to not push your policy to hub, which helps if you are trying to run things locally without going into a hugging phase. And then finally, if you need to resume from the last checkpoint, you can of course run something like Python Lerobot bot scripts train.py config hash equals output / train / add. You basically train on the output train. You basically train from the train config.json from the checkpoint, and then you specify resume equals true so you can continue training. Training will automatically complete once the loss stops decreasing, and once training is done, you can of course upload the checkpoint with this command over here. Hugging face CLI upload your username / act SL11 test, which you should, which is the same directory specified when you start training, outputs train, directory name, checkpoints last pre-trained model. You can also upload intermediate checkpoints by replacing the last section of the command with your intermediate checkpoint's name. You can find all these in the folder where it's put. Yeah, you can find all this in the cache folder. Cache hugging face, the robot, and you should be able to find it there. I won't bother for now to save time, but finally, you can record evaluation episodes. With commands like I swear I had it here somewhere. Okay. You can record evaluation episodes if I'll just be modifying this command here to make it easier. Or we're not, I'm pretty sure about the stat. Yeah. So you specify your robot type, your robot port, your robot ID. Note that we also have our cameras here, and we are not using a tele-op arm because we're recording evaluation. I am choosing not display data. You create a repo for the evaluation data, your single task, and then finally you link to the policy you just recorded. And then once you're done with this, you should be able to run and evaluate your policy. Thank you for watching.